Hello friends, welcome. And in this video we are going to build a simple artificial neural network. So what is artificial neural network? It's a computational model based on the structure and functions of biological neural network. Information that flows through the network affect the structure of the artificial neural network uh, it because it changes, or we can say that it learns in a sense based on the input and output. So we can say that artificial neural network is just a simulation of our brain basically. But artificial neural network is simple, our brain is highly complex, and if we just work more on them and make just a highly group of neural network and combine them with various algorithms, we can just make good machine learning tools. So for this neural network we are going to use the perceptron model. So in machine learning, perceptron is an algorithm for supervised learning for binary classifiers. It's a type of linear classifier, that is a classification algorithm that makes its prediction based on the linear predictor function, combining a set of it with the feature vector. So this perceptron algorithm was invented in 1957 at the Cornell Aeronautical Laboratory by Frank Rosenblatt, funded by the United States Office of Naval Research. So let's now jump to our code, and we are going to write our code in Python. And I must say that Python is very good language for machine learning, and it has a whole lot of library for that. So currently I am using an Ubuntu, and if you are a programmer, then I must say you must use Ubuntu. It's very good, and it's even better. It's better than Windows. I just don't like Windows. Windows is not for programmers, it's for gamers, I think. And Linux is for programmer. So let's define our interpreter line. Now let's import our library. We are going to use numpy. Let's import some of the functions from numpy. From numpy, import exponent, array, random, and dot. So we have imported these four functions. Exp is the natural exponent. An array creates a matrix. Dot help in calculating dot product, and random help in generating random numbers. Let's create a class named neural network. Define its constructor. Now we're going to random seed the random numbers so that we get the same random number every time. And it's needed because we need to train our model again and again very high time. Like we train our this simple model, we are going to train our nearly 10,000 or 20,000 or 40,000 times. And how many, and the time which we the number of iteration increases, and according to that the performance also increases. If you train it very less time, then the result correction is also very less. As you increase the correction, the accurate prediction increases. Now let's define the weights. Equals to random dot random 3, 1. So it's create a matrix of 3 and 1, 3 rows and 1 column. Let's define sigmoid function. We have defined the sigmoid function. Now we have defined the sigmoid derivative. Return 1 x into 1 minus x. So we also define the sigmoid derivative. Now we are going to define the train function to train the neural network. Self inputs, outputs, and the number of iteration represented by I. For it in range I. Now we are going to calculate the error. First we are going to guess the result. So the guess of the result is based on the input and our random weights. We are just going to do the dot product of our weights and the input. So for that we'll create a new function later on. Let's first define it here. We will call it think. Is basically like human brain is thinking and carrying out the processing information, giving us the result. So in beginning it will give us random result which does not have any sense in the beginning, but when we train it again and again, it will just give a correct result. Now we will find out the error. Outputs minus guess. Now we are going to adjust our weight. So we are going to carry out the dot product of inputs dot t. So dot t function here transpose the matrix, basically transforms the matrix from horizontal to vertical. So our second argument is error into sigmoid derivative of guess. So now we are going to adjust our weight. So this is our training function. Now let's define the think function. It will going to return. It uses sigmoid function, and we are going to carry out the dot product of the input and the weight. So our this function is also complete. Let's define a main function. Create an object of neural network. Let's print the random weight starting. Random weights. Now print n dot weights. Now let's train it. Training. Now we are going to first we need to define the input. I is equals to array 0. So we are going to use this zeros and one because perceptron is a binary classifier. So we just first give it a training set. So let's define our second input. So these are our training data, and it will just learn from this 4 training data set. Output is equals to array 0, 1, 0. So this is our training set. Now let's train our provided input, output, and number of approaches, number of iterations. Now let's print out a new weight. Print new weights. Print n dot weights. Now let's test the new condition. New a test data n dot think array 1, 0, 0. So this is our simple perceptron is going to use this training data, and after training it 10,000 times we are going to test with this simple test data. So let's run this. Save, open a terminal, provided it proper permission to execute, and let's see if it's run without any error, I think I haven't defined that main function. Just need to execute that main function. So we have an error here, sigmoid derivative is not found. So I think there must be any error. Sigmoid derivative at the line number 21. Self, it should be self dot sigmoid derivative because our function is defined in that class only. So now we can see, let's do one thing, just make a separate line so that it just looks neat and clean. Now let's run it again. Now you can see we have random weight in the beginning and we are training it. Then you can see the changes in the new weights, and now you can see it is giving result 0.999. This means that it's 1. So it's giving the correct result, that is 1. Now let's do one thing. Now let's test our training data again on this and check if the answer are correct. Now you can see that it's nearly 0 1 1 0, and our the answer of our training data is 0 1 1 0. It's same. So you have seen we have got the correct result. Now let's do one thing, test that our data before training and after training. Let's remove these, remove this new weight and array 1 comma 0 comma 0. So it's our training data. So this is before training and this is after training. So this shows us the difference between our training. I think my console has stopped working. Let me just open new one and perceptron.py. Now you can see the difference. Before training it's giving us 0.60, which is less accurate, and after training it's giving us 99.9% correct result. If we give this more training, you can see the difference. You can see this, we have 999937, now we have 99999697. The more you increase the training, the more accurate result you get. Now we will see. Now you can see we have got nearly 1 correct result. If we just round this off, we will get nearly 1. So that's all for this video. If you like this video, hit the like button, and if you have any query, comment below and subscribe to my channel for more videos. Thank you and have a nice day.